we saw another key technology being unveiled there, which is specifically nanite, the sort of micro geometry system that's in Unreal Engine 5. Now, famously, when we first looked at those original Unreal Engine 5 demos, there's a lot of stones and rocks going on. Then we went to the Matrix City, not a lot of foliage, trees there. No. And it wasn't really a system that was compatible with nanite, the right. concept of vegetation. But they made a special focus of it here. They also showed us how they did it. And this is good news, right?
Yeah, so this is cool because they did technically preview vegetation. It might have been 5.3 or 5.4 using nanite, but the authoring of those as well as the fallback system for it was different, where in games for a really long time, and I mean a really long time, the way you would do small, highly detailed vegetation or just even large vegetation would be you'd have a big two triangles slapped together to form a quad. So it's a rectangle or a square. And you would have a texture that has an alpha value of 0 or 1. So transparency would be like your 0, and your 1 would be the place where it's full bright, or not full bright, but you could see the full value of the RGB there. And that's how you would have essentially a couple of leaves or a grouping of leaves or the needles on a pine tree. That's how you'd represent them with these transparent quads of geometry. And the actual leaf detail would just be 2D. It wouldn't face the camera necessarily, but it would be as a 2D element in the game world. And there's a lot of reasons why that's problematic. One, when you rendering those things is expensive. Transparency is pretty much always expensive. So you'd get like overdraw issues and whatnot when you get really close to trees, and a lot of them would be overlapping. How do you call out that information? Also, how do you level of detail that information, which is essentially just a texture attached to a piece of geometry? Usually geometry, you decimate it at a distance, right? But it's already the simplest form it can be, right? It's like two triangles slapped together with a texture on it. So how do you level of detail that? And usually that causes in games level of detail transitions on things like trees and bushes and grass to be quite obvious. So it's performance intensive. The level of detail behavior is intense, as well as then just doing the rendering and lighting on it, like ray tracing. They've come up with kind of mitigation strategies in ray tracing. We saw recently in Assassin's Creed Shadows, they would, in the ray tracing structure, they would purposefully reduce the amount of triangles and trees instead of having to trace against these quads with textures on them, which are transparency, and they would invoke an any hit shader, which is expensive. They would reduce them into like kind of not super representative, just triangles that would look like leaves. And that's like a mitigation strategy that is kind of not a great point to be at for performance as well as visuals, depending upon what you're looking at. So there's a lot of problems with the way traditionally vegetation has been done. We've seen NVIDIA try to get around it with OMMs, opacity micromaps, where they avoid the problem altogether by representing it as a different type of geometry. But that's, once again, is just another midway point to actually solving the issue, which is instead of rendering these things as alpha cutout cards, you'd actually render them with real geometry, which is kind of what we want at the end of the day for fidelity purposes. And Epic's take on it here is pretty interesting. They leave the leaves of the tree, and not necessarily all the branches, but maybe like the more twig elements on it, as like highly instanced like rotations of the exact same object, just placed all over the tree. And as the camera gets further away, that decimates in the normal way using nanite geometry that we've seen in many games in the past. But then as the camera pulls back even further away, when it gets like sub-pixel size of that element of whatever we're looking at, it transitions into a voxel representation of it. So it's volumetric. And based upon what I can see in the trailer, they show it like really quickly transitioning on one tree while the camera's close. That's not how it would be in game. They're doing that for illustrative purposes. You can see what looks like 8 level of detail transitions. for how coarse these voxels are. And that's really cool because at a certain distance, you don't see individual triangles anymore. You just see like a color value. But it needs to still be volumetric because things like shadows have to apply to it, lighting has to apply to it. And here they thought voxels were a good fit, and it does look like it in the demo. It was pretty hard to see many level of detail transitions at all, even at a distance. And they show off very, very nicely how it also plugs into the lighting and shadowing system. So you can see direct shadows being cast from the sun on it, as well as presumably other lighting effects can apply to it. But still, I have a lot of questions about this. Voxels don't play into triangle RT, which the demo was showing off. It was showing off hardware ray tracing. So they need to talk about or describe, or maybe they don't even have a solution yet because this is just a preview of 5.6, of how indirect lighting can bounce off, or you can actually bounce rays off of this thing that isn't just screen space. And there's good reasons to have that, because you can imagine a game like Avatar Frontiers of Pandora. Above you, there's like a huge canopy that's like 50, 75 meters away. If rays didn't bounce off that canopy in some capacity, you'd have like really bright lighting really far above you. And it wouldn't make sense because it's a canopy. So there's some things that they haven't talked about here that I'm very curious about how they solve it and if it's solved. But for the purpose of the demo, this is really big because we're seeing a great way to level of detail vegetation at a distance and keep it performant. And I think that was obvious by the fact that we're seeing it at 60 FPS and also not showcasing this level of detailed behavior at the same time on a base PS5, which is the most impressive part.